Continuity at a point x equals a for a function f of x. Well, I think we have kind of an intuitive idea what it means to be continuous, or what it means when we have a continuous function. If we're graphing a function and we have to lift our pencil up at a certain point, then we know that there's a break there, and we have a point of discontinuity, and that's sort of our intuitive idea of what it means to be discontinuous at a certain point. But we want to be a little more rigorous than that. And I might add the caveat here, when we're talking about continuity, we're talking about an interior point here. Endpoints are a slightly different matter. So anyway, I've got three conditions for continuity. Two of them are necessary, and the third is both necessary and sufficient. So the first one is that if a function is going to be continuous at a point A, then f of a has to be there. It has to exist. The second condition is that if f of x is continuous at some point A, then the limit of f of x as x approaches A must exist. And the third, the necessary and sufficient condition, is that if a function f is continuous at A, then the limit of f of x as x approaches A has to not only exist but equal function of A. Okay, so we're going to take a look at three discontinuous points here on this graph. A1, A2, and A3. Here they are, A1, A2, and A3 of this function. This is function of x here. And we're going to see why, according to these three conditions, why this is discontinuous at each one of these points. Well, I'll take A1 first, and I notice the first thing I notice about A1 is a hole right here. Well, f of A1 does not exist. Therefore, it doesn't meet this first necessary condition. So we have a discontinuity at A1 for sure. At A2, the first condition is satisfied. This is a necessary condition, but it's not sufficient to say, just because f of a does exist right here, that we that it's continuous. The limit of f of x as x approaches a must exist. That's the second condition, and notice it doesn't. We don't have a limit here. We have not a two-sided limit anyway. It gets closer and closer to a point right around here on the y-axis, and down here it's a close point down here, so they don't meet up. So therefore we have no limit there. So we have a discontinuity at A2. Even though it satisfies the first condition, it doesn't satisfy the second. Now we kind of roll on over here to A3, and the first condition is met. F of A3 does exist. Here it is. Does the limit of f of x as x approaches A3 exist? I look here. Oh yeah, it does. The limit exists. And but does the limit of f of x as it approaches A3 equal f of A3? Oh, sorry, it doesn't, because A3 is down here and the limit is up here somewhere. So it doesn't meet this third condition. Therefore, we have a discontinuity at A3.